Good afternoon, everyone. So yeah, my name is Ashok, co-founder and CEO of TracXon. My title, of course, is Towards Semi-Transparent Micro-LED Displays with Printed Backplane. Two disclaimers. One is that my definition of micro-LED is from the Stone Age, from the beginning of the micro-LED era, basically, so 100-micron feature sizes. And the backplane here means not TFT backplane, but printed backplanes with screen printing. First, a few words about TracXon. We are the first fully integrated foundry for printed electronics. Founded two years ago here in Eindhoven as a spin-off from Holt Center. My previous speaker, of course, introduced Holt Center, a leading R&D institute in this field. Our expertise lies in roll-to-roll and sheet-to-sheet printing of circuitry and SMD assembly of components on the printed circuitry, including multi-mix complex assemblies. We are a pure-play foundry in the sense that we do not bring products to the market, but we co-design, co-develop, and produce for B2B customers across domains. Some of you might not know the history of this region. I'm not sure. We are called here the Brain Port. That's because Netherlands has a very famous airport, Amsterdam Schiphol, very famous seaport, that's Rotterdam. But of course, here we are smart people here, so we are called the Brain Port. This is apparently the smartest square kilometer in Europe, and that's the reason for this name. Our expertise, as I mentioned, lies in printed electronics, offering vastly enhanced user experience and sustainability compared to traditional electronics, traditional PCBs. Some key aspects are we enable products that are flexible, stretchable, formable, and conformal in large area. We base our processes and technologies on additively printed circuitry up to 7 square meters per minute by roll-to-roll screen printing, and also do complex multi-mix assembly on that circuitry without compromising the form factor or the shape or the geometry. The technology itself is very sustainable. You see on the next slide. Basically, we print on recyclable polymer foils with additive technologies, and eventually we are going to go to cradle-to-cradle electronics, which is the motivation and the goal of TracXon. Some, let's say, data to back it up. This was a study carried out by the Vrije Universiteit, Free University of Amsterdam, to compare TracXon's technology with traditional PCB technology. We are 5 times lower in terms of CO2 emissions, in terms of material consumption up to 12 times lower, 10 times less waste, highly energy efficient, and of course, at the right production scale, lower cost compared to traditional PCB. Last slide about TracXon before I go to the main part of the presentation. We are technology-driven. We cut across multiple application domains. We serve B2B customers in display and lighting, in automotive human-machine interface, in health and wellness, as well as IoT. But of course, this talk is about the display and lighting aspects. We enable display and lighting devices that are ultra-thin, transparent, and conformal. I'll give you a few examples on the next slides. But first, let's start with our philosophy with respect to lighting and displays. We consider a large area in terms of sizes and fine features to be the sweet spot. So basically, we can print very large areas, circuitry, very fine circuitry, and populate components down to micro-LEDs so that we can create devices that are both large with fine features for applications such as these, what you see on the screen. We have customers asking for glass integration of lighting and displays. One example is shown here, automotive sunroof with a very large area, basically 1.5 meters by about 1 meter. During the day, of course, the sunlight should pass through, and in the night it creates a starry sky effect. And the basis is indeed a transparent foil that's laminated between two glass panels in an autoclave process. And that foil has very fine circuitry that you almost cannot see, and very small LEDs distributed all over the surface. That's one example. Another example is for the front and back window, also side windows, some kind of display clusters or signages with higher density LEDs locally, but still with a single foil covering the surface. So all these can be enabled also in terms of the thin form factor only by this printed electronics technology with ultra-thin flexible foils. And of course, all at very high, let's say, integration accuracy and reliability, because the lifetime needs to be several years and not several months or something like that. In addition, there are also customers asking for, this is one example, for smart buildings, for creating huge advertising in skyscrapers. One customer says, well, I would like to have an advertising display that's a whole facade of a building. when someone views from 50 to 100 meters distance, every single glass panel in the